Hey everyone, this is Ms. Fisher, and this is a video to help you with the Go formative, which is going to ask you questions about the CS Awesome and the Repl.it for 09-02. So in class, we talked about this idea of polymorphism and how you can declare a reference variable of type superclass. In this case, we can see that writing utensil is a superclass or a parent class, and we can actually assign it to an object or an instance of a class, which is either a subclass or a subclass of the subclass of the superclass. So as long as there is a relationship among two classes, for example, in this case, a marker is a writing utensil, and a gel pen is a pen, which is a writing utensil. So therefore, gel pen is also a writing utensil. You can assign a gel pen instance to a writing utensil reference variable. Okay, and the same thing with these other three examples. So this is especially useful when you declare a collection. So when we talked about arrays and array lists and how we can hold different types of writing utensils. And so therefore, if we declare an array of type writing utensil, we can assign to it different types of writing utensils. We can assign to it a writing utensil. However, we can assign to it a gel pen instance, a pen instance, a marker instance. If you have an array list of writing utensils, then we can also add markers or pens or just any object as long as there is a relationship with writing utensil. Okay, so we're going to go ahead and take a look at Repl.it 9-2. And here in class, we talked about how to declare ballet dancer as a subclass of dancer. And then we talked about how dancer is a subclass of performer. And then we also overrode the perform method here. So we called on super.perform, okay, so that it would call on the perform implementation of the performer class, which prints performing for an audience, and then it will print dancing on stage. But then in ballet dancer, we actually called on jeté and pirouette, which will print leaping and spinning, but then we're going to go ahead and call on the dancer implementation of perform. And in this case, because dancer is a superclass of ballet dancer, then this perform is the implementation that is defined here within the, within the dancer class. Okay, so when we run the program, we see that beta in the main class is the name of the instance of the ballet dancer. In this case, we've got beta, who's 16, we're size 6 with point shoes. And then when we print beta, it's going to say beta the performer, okay? Because if you take a look at the performer class, the toString, it returns just the name and the performer. And then we're going to call on practice makes perfect. And notice in practice makes perfect, it takes a performer P. But we can actually call on it with beta, which is a ballet dancer. And this is, again, the power of polymorphism, because beta, even though it's of type ballet dancer is a performer. So even though the parameter type down here says it takes a performer, it's okay to pass a reference to an object as long as that object is a performer. So it could have been a performer object, just like we did up here, where we call in practice makes perfect, and Spencer is a performer object, but we can also pass a ballet dancer object as a parameter, because again, a ballet dancer is a performer. Okay, so one example of polymorphism when the parameter, the formal parameter data type is a type, and you can actually pass as the actual parameter any object, right? A referencing object where it has that is a relationship with this data type, which is performer. All right. Now, for part 2, let's go ahead and assign, it says for each spot, performers, 0 gets, let's spell it correctly, 0 gets new performer for index 0, and then we're going to go in and assign it at index 1 and 2. Instead of performer, we're going to call on the dancer, and all of them have no argument constructors. And then the next thing we're going to do is ballet dancer. Okay. We're going to go ahead and use a for each loop and print the call to the toString. But we have to go ahead and override the toString. So each performer P in performers, the nice thing is, again, when you take a look at the first instance here, there you go, sorry about that. Okay. I don't know why that did that. That's strange. There we go. Well, performer P, again, is declared as a performer type, but that is okay, right? Because we know that even the first reference is a reference to performer. The second one is a dancer, but a dancer is a performer, so we should not get an error because of polymorphism, okay? So this being able to declare it of a very general type, in this case, type performer, both dancer and ballet dancers are considered is a relationship with performer. So we can go ahead and declare that data type in the for each loop as performer, very similar to what we did down here for the parameter. And then the last thing we need to do is actually override our toString methods. We want to say, instead of Twitch the performer, we want to say Twitch the dancer and Misty the ballet dancer, okay, not the performer. We want to customize the toString. So let's go ahead and customize it. We're going to declare it as public string toString. And then we're going to return the name, but name is not in this class, right? It's actually inherited, but it's declared in the performer class. So let's just see what happens first. And we want to say the ballet dancer. And that should be a string literal. Let's just make sure, I don't remember what it's supposed to say. Yeah, Misty the ballet dancer. So let's go back here for ballet dancer, blank and plus, and we don't need that white space, plus the ballet dancer. Now, I can already see this has an error, but if we run it, says, name has private access. So we're going to have to take a look at the performer class and see that name is declared private, but we do have an accessor method, which is public. So we're going to have to call on that. So let's go ahead and call on get name, public accessor method. And when we run it, nice. Now we've got instead of Misty the performer, we have Misty the ballet dancer. And this is going to look very similar. In the dancer class, we need to override the toString in the dancer. So instead of, we're going to have to call on get name, because again, this is a dancer class. It just inherited name, which in turn, the ballet dancer in turn inherited name from dancer, right? It's interesting. But here we're going to say the dancer, Twitch the dancer. Okay, so now when we run the program, we've got And these are our default values from our no argument constructor. Halsey the performer, Twitch the dancer, Misty the ballet dancer. Okay. And we're going to run our test. I think that's all I asked you to do in this project. All right. So I hope this was helpful, and I'm going to create another video to help you with the CS Awesome assignments. Okay, bye everyone.